Hello, I want to talk about the three factors that affect wind speed and direction. The first of the three factors is going to be the pressure gradient force, but to understand what that is, let's look at this map first. This is a map with isobars. The isobars are lines that connect all points that have the same air pressure. So if you look here, you'll see a line that's the 1008 millibar air pressure line, and if we move in this direction, that the isobar values or the air pressure values are increasing by 4 millibars when we go from one line to the next. So the contour interval between these lines is 4 millibars. This is equivalent or analogous to a topographic map where the lines will represent elevation, and going up this way would be equivalent to climbing a hill. Where it says high, that would be the peak, that would be the top of a hill. So the pressure gradient force is the force that happens because pressure varies from one place to another. So gradient means change over distance. So when we go from high pressure to low pressure over a given distance, then we have what's called a pressure gradient force. On this side, we see a high pressure, high air pressure. All these molecules, these are air molecules, they're all bunched up together and pushing against each other and pushing the wind or the air in this direction towards the low pressure area. If we look at the lower map, we see the isobars here mapped, and here the contour interval is 1 millibar, so it's going from 1020, 1019, 1018, and again going from high to low pressure, but notice, and this is important, moving perpendicular to the isobar, so straight across the isobars. Okay, so at a 90-degree angle to the isobars. Here we see the again a picture of high pressure on one end, low pressure on the other end. The isobars going from 1100 millibars to 1020, so a difference of 80 millibars over a certain distance when moving this red arrow perpendicular to the isobars straight across the isobars from high to low. There's a similar example, except that now we're going from 1100 millibars to 940 millibars, so the difference is now 160 millibars. So we are moving across a bigger drop in pressure. Okay, so the isobars now are all squished together. This would be analogous to having contour lines that are close together, packed together, and that would represent a steep hill. So in the same way, the contour lines that are packed together here represent a steep drop in air pressure, making the wind move faster. This would be as if you were dropping a rock down a steep hill. You would expect it to roll down faster than than if you dropped it over a more gentle slope. The second factor that affects, in this case, wind direction is the Coriolis effect. The Coriolis effect is an effect that happens due to the Earth rotation and its shape. And basically what it is that anything moving over the surface of the Earth will be deflected to the right of its direction of movement in the northern hemisphere, and we see that here. And here there's the original direction, and the actual movement is to the right. And in the southern hemisphere, it will be deflected to the left of the direction of movement. So this happens to anything that's moving over long distances, such as air currents or wind currents are affected by this. And the last of the three factors that I wanted to talk about is friction. Friction tends to slow down wind near the surface. High elevation winds, they can travel faster because they have little to no friction. Okay, when you combine these forces, if we only combine, if we only had high elevation winds and combine the pressure gradient force, the red arrow here, and the Coriolis effect, we will have winds that travel parallel to the isobars. These parallel lines are isobars. But for our purposes, for this class, we really won't worry about high elevation winds. We'll be looking at surface winds. And when you have surface winds, you have to combine the pressure gradient force, which goes, again, perpendicular to the isobars, with the Coriolis effect, which acts to the right of the direction of movement, and with friction, which tends to slow down wind. When you combine all those three, the net result is that wind travels still in the general direction from high to low pressure, but at an angle to the isobars, so at an oblique angle to the isobars.